Hello everyone and welcome to the Matrix, I suppose. Today we're going to create the falling code effect and it's going to be a lot of fun. We're going to create this in geometry node with some texturing as well. This is what it looks like. If I play this, we got the code falling down nicely and yeah, we're going to create that nice setup. Alright, hold up. About 87% of you guys are not subscribed yet. And so if you do enjoy my videos, please leave a like, a comment, subscribe. It will help me out a lot. Thank you so much and let's carry on. So let's get started and create a new file so we're all at the same place. So we can just keep this as a cube, but I'm just gonna delete this and add, let's say, a plane. We need something to emit our instances of, right, the falling code. So that's what I'm gonna start with a nice plane. Now open up a new window, set it to Geometry Nodes Editor, and let's go. And let's hit New, and we're ready. So we're gonna create something in between the input and the output, and we first need to add some points that we can actually use to fall down. So we are going to press Shift A and find a Distribute Points on Faces node and just add it in between. And that way, right away, we get a nice cloud of points, a nice surface with scattered points. So now let's drag this to the right because we want to do some magic in between there. And first things first, we pretty much want to set a position, right? So we want to move the points down, sort of. So I'm gonna do that with, and I'm just gonna do that with a simulation node first, because I think it's gonna be helpful. So let's add that there. And let's connect this to the output, and we've got a simulation set up and ready to go. And I want to move my points down every iteration, every frame, right? So we can just find a set position. There we go. And we can use an offset that we want. Okay, so what we can do is actually use a value for this. And perhaps we can use a vector, and let's just set this to minus 0.06 and connect that up here. Just to check this out first. This is the speed at which the text will be falling, right? So perhaps that's a bit fast. Maybe we can set this to 0.04. A bit better. We'll see how this looks once we get the actual text in there. So this is going to be our speed value that we can be changing later on as well. But for now, we actually need to think about how we're gonna make it so that this is gonna turn into lines of text or code, whatever you prefer. And how do we get the text in there? It's another good one. And how do we get the text to actually stay in place, right? Because we want the instances to fall, right, for the text, but we want the text, let's say 1001, we want this to not move down with that Z value, but we want to let this text actually stay in place, right, so that it looks like it is just something hovering over text, visualizing what they look like. And that is pretty much what I want to create here as well. So to do that, I think the best way is to actually create multiple instances of these points in every frame. Then we're going to join them up into a nice curve. And then we can actually unwrap that curve to get a nice falling plane that we can add a texture to. And this will have that curve parameter of a factor from 0 to 1 on the ends. That is what a curve parameter, a spline parameter of the vector value shows. And then we can actually use that to unwrap our curve profile to whatever we want of a texture that has the text, right? So I already created a nice text pattern, right? So I'm gonna import that. Actually, I'm gonna press Shift A, mesh plane, and I'm just gonna hit shader editor and new and just get this image in there quickly so you can see what I'm using. Here it is. Let's go to rendered mode for a second. And there we go. Perhaps we should set this to cycle, alpha. There we go. So this is all just zeros in a bit like I did in Photoshop. I will add this image to the video as well. And you could create this stuff too if you are familiar with, for example, Photoshop or anything that creates layout text, because that's really what we want, right? We want each of these curves that we create to just cycle through one of vertical columns, right? So that's beautiful. So I created a grid with more zeros. You can do this as well if you'd like. And this, the one thing you need to remember is how many columns you have. So there's 100 columns here, I believe. And that is something we need to remember for later on. So remember that. So for now, we could just go back to solid view and just set this to the side in case we want to see that later. So let's go back to the geometry node settings, the setup. So I want to add particles every frame so we can actually turn them into curves. So let's hit another simulation zone, and connect that there and there. And let's actually find Shift A join geometry, and we will join the previous geometry every frame, which means that if we now play this, we're actually going to be getting points every frame that it's gonna remember, right? So all the points will be remembered, which is what we want. So there we go. A nice little setup. Beautiful. Now what I want to do already is set up the age of my particles, right? Because I don't want these particles to be staying forever. It's gonna make Blender incredibly slow the longer we play our animation. So they need to be deleted after a certain time. So to do that, we can find Shift A, a store named attribute node, and we can actually store a named attribute. And the trick here is to make these names the same. So H, and H, right? We're gonna store a value of H, and the value that we store is gonna be H, but every frame, every simulation cycle, it's going to math at 1, right? So that means every frame this is played, the simulation is played, is gonna store H with an increment of 1. So every frame you'll have H plus 1, which basically means we can give an H to a particle. So connect that up is important, and then we can find Shift A delete geometry, and then we're gonna use the same named attribute H that we're gonna compare, and we're gonna set this to greater than. So anything, any particle that has a larger H than, let's say 22, is going to be deleted, right? So if you play this now, you can see at some point the points are going to be falling down, right? So that means that there's 22 points now, and the 23rd will be deleted, right? Beautiful. Now I want to also add new points every frame. So how do we do that? Well, we need to change the seed, right? We just need to change the seed every frame, and that we can do with a driver. So hashtag frame, hashtag means we're going to add a driver, frame, and there you go. Now every frame, this value is going to be changing with the frame count. Now to actually make that show, right, we need to move this to the left a little bit and find a join geometry so that every frame we're actually going to be adding that new seed of points, right? There we go. So now play that, and you'll see we got a lot of points spawning. So let's decrease the density to perhaps 3. And there we go. Maybe 2 will be fine as well, right? So now we're going to get new points every frame, which is perfect. So now we can actually focus on the rest. So I'm going to group these 3 nodes, Ctrl G, and I'm going to expose the H and exit the group. And we're going to call this delete old particles. And then this is going to be the H, of course. So I'm going to keep that close to our output because I want some stuff to happen in between there. So first of all, we need to join these particles up to a curve. How do we do that? Well, we can spawn an instance on each of these points, right? That is going to connect between 2 points. So we need a curved line that's going to connect from point 1 to point 2 between every point, right? And that's going to be connected, and then we're going to merge that and turn it back into a curve. So to do that, we need to find Shift A, an instance on points, and we want the instance to be a curved line, and we don't want the Z to be 1, but -1. We want this to go down, and the scale of this curved line has to be the speed in which these points move down, right? Because if we have a point, here, the next frame point here, then the distance in which this point moved is, of course, the value we set for the Z velocity here, right? So every frame is gonna be a distance of 0.04. And that value is something we can just use for the scaling of our line, right? So we could just drag that value into the scale and it's gonna be perfect. Beautiful. So now we can actually just merge these points. So Shift A and curve to mesh, right? When we want to merge points, merge a mesh, we need to first turn it into a mesh, merge by distance, value is fine, and then mesh to curve, right? That way we've got the same curve, but we've actually connected the points into one curve. So if you want to visualize if it works, we can just find another curve to mesh, right? Because we now want to apply an actual profile curve. And we can drag this out to a curved line. Before this is actually going to work, we need to realize our instances, right? Because these are all still instances. So we want to find a realized instance. And perhaps we want to do that before the merge by distance as well, right? So let's just do it right after we instance on points, just for safety reasons. There we go. Now we've got this in the Z direction, but I want this in the Y or X probably. So let's set this to 0 and let's add a little bit of an X value of 0.015 perhaps. And now if we play this, you can see we're actually getting these nice streaks, right, that are falling down and coming out to vision again. Isn't that beautiful? So now we need to work on actually applying materials to that, right? So we want to apply the numbers of the grid here. So what we're gonna do is we can just drag out another window, set to shader editor, hit new, and let's call this material code. Beautiful. Then we want, hit home if you can find it. I want to delete my principal BSDF and find an emission. And I want the color to be that image texture that we already had, which is now the matrix text. And that is going to be our color. And we're going to find a mix shader there with the alpha of that set to the vector. And a transparent BSDF here as well. And I think we need to swap that around like that. And then we don't really want to connect the color to the color here as well. We want to just connect that and set this to green. And make sure that you have transparent in the top, emission in the bottom. Okay. And then we've got our image pretty much set up, right? I'm going to hide this so we can work now with our actual geometry nodes. So we have that set up. Now make sure that we apply it in the geonode as well with a set material and to code. There we go. So let's go to render view and see what we've got. Nothing's working yet. And there's a simple reason, because we don't have a UV map yet. Okay. So we need to somehow create a UV map, and we can create that quite easily. So let me open up a UV editor, and a UV map is a 2D vector with an X and a Y component. And that information is basically what we need to set up a 2D vector UV map, right? So what we have here is a curve to mesh node, right? And this is a curve to mesh node that's going to use a curve line. Let me zoom in onto one of these objects, right? We've got a curve line that is basically the X value here. That is X. And then we've got a Y value that is basically the length of that initial spline, right? Y. And that is this. So the initial mesh to curve input that we have here, that is our vertical component. And the curve line is basically the X component, right? Which is the extrusion, pretty much the curve profile. And if we combine these two, we've basically got that UV map here with all the information. And this image that we're going to be unwrapping it for has got a grid, right? Perfect straight lines, has got a grid. And for each of these lines, for each of these strokes, we want to use one of these vertical columns as well, right? So we've got a map each and one of these meshes of the curve to mesh to one of these columns, right? So that is what we're going to be setting up right now. And we're going to do that simply with, let's zoom out, a capture attribute, because we want to capture a value right here from this initial curve input. We want to capture the y value, and for the curve line we want to capture the x value, and we're going to combine those two in a vector for the UV map. So let's move all of this to the right, and let's add this here, and let's add one here as well. And what do we want to capture? Well, we want to capture a value that describes how far along a curve a point is, right? So let's say this has to be 0, this has to be 1. Then we want to capture, of course, the values in between that and store that as our y value. Same for the x. And to do that, we can use a spline parameter as the factor, okay? And that factor value basically gives us that 0 to 1 value from 0 to 1 of the complete length of the curve. So that is a perfect value to use for our x and y values. Then after we turn this into a curve to mesh, we want to store that as a named attribute, because we want to apply this in the shader editor, which means we need to transfer this from the geonodes to the material. And we can store this as store UV, and it's of course a vector, and it's a 2D, so face corner vector in this case. And we want to combine these two values in a combine XYZ, so X and Y, and we can also swap these around if we want. Doesn't really matter whether this is going to be X or this is going to be Y. We'll deal with it accordingly. And I'm just going to drag this into that vector there. Now in the shader editor, we can now apply that vector as an attribute set to store UV. Same naming, remember. And just drag that in there. And right away you can see something beautiful is happening. It is unwrapped, but it is now unwrapped in the entire range of that curve, right? Which means that our entire square UV is now mapped to our rectangular shape of that area. And we don't really want that, okay? What we do want is for our y value, let me just drag this around just so that we're working with the same values we're showing here, right? So let's do that. So the x value is the value of our curve line, and the y value is the value of our vertical component. So in the x direction, I want the entire range, but divided by how many columns I have, right? So find a math node set to divide, and divide this by 100. And there we go. So it's already picking the first column now. It's not completely central because that's not how it is in the grid as well. The text, the font I chose was just not aligned in the center, but it's fine, right? We don't see that. Whether it's going to be in the center or on the left, it's fine. And then in the vertical component, we need to do some mapping as well. Because now, for no matter how long that spline is, it is going to map it in the entire one direction of the y value, right? So whether it's going to be short or long, whether the curve is going to be short or long, it's going to map it to that square, right? And we don't really want that, because now if you play this, it's going to be stretching out because, well, this value is going to be stretching out as well. So we need to somehow fix that, okay? And we can fix that by using a spline length node, right? And this is going to give us the length of each spline. And that means that we're going to be able to remain a constant value of that y scaling, because we're actually going to be multiplying with a value that's going to be changing the same way, right? If that makes sense. So let's find a math node set to multiply for that y value, and let's multiply by the spline length. Now this is not going to work, and there's a simple reason, and that's because the spline length is not really going to go across well after a mesh. Okay, so we need to capture this value or store it as a named attribute before we're converting it. All right, so we do need this multiply value, but let me move all of this a tiny bit. It is getting in my way. But we want to just store this first, so this length value. So let's find a store named attribute for now. We can just set this to float, is fine. And let's call this spline length for spline length and connect that there. And we can just find a named attribute. Perhaps we could have used our capture attribute the same way. But let's just use this, right? Because then we can also see, and that's the nice part with store named attributes. I'll show that. And then we can apply a named attribute called the same, spline len, and we can use that as the actual multiplication vector, right? So we're not using the actual length here, but that stored attribute there. And you can see that now it's already working. And the fun thing I was talking about is if we go to the spreadsheet, we can actually see how that value is stored. And that's something I use, but I'm not completely sure if it's going to work out or not. I will use a store named attribute into the instead of a capture attribute, so I can actually tell what that value is doing throughout my mesh, right? So if I Control-Shift-Click on this mesh to curve, we don't really have the values, but if we capture the spline length here, you can see that at the control points, we've got a spline length here that's gonna get captured, and then once we go further, when we convert to a mesh, we can see how values are then transferred to the vertex, for example, in this case, right? It's gonna go from control point to vertex, and we can see that value is captured, stored properly, right? Beautiful. So now we've got that value set up, but if we play this, you can see it is upside down, okay? And that is annoying. We don't want this to be upside down, but luckily for us, we can just flip that value around with a quick multiply node. Math, set to multiply, and we can just find a -1 value and it will be flipped, right? That's just how that goes. And now you can see it's actually playing, right? And the numbers are actually staying in place as well while we play that. That's quite nice, isn't it? And then after that, we're gonna delete those particles completely. Nice. Okay, so we've got a beautiful setup that works, but I want to do some more magic, right, in terms of how it fades in and out. Okay, I find that quite important here, because it's too harsh and it's there for too long, and it has to be that nice fade that it has in the show as well, in the movies. So let's go back into the shader editor, and we've actually already got a value that stores the age for us, right? So we can do some magic with that value. So if you've duplicated this attribute here and set it to age, and let's Control-Shift-Click on that, we can see how that value changes, right? So we've got an age value, and this is age 0, the first particle, and the top is age 22, which is where is the delete value? Here, right? The 1022 value. So what we can do is we can actually map this with a map range node from 0 to 22 is going to be from 0 to 1. That's just going to make sure that we got a nice range that we can work with. And then we could drag that into a float curve that we can use to control where our alpha is going to be 0 and where it's going to be 1. So if I drag this down and drag 1 point up in the middle, you can see that we've got a value that's darker at the start and at the end. So if I drag this point more down and this a bit more down and then add a bit more of a bump here, we can see that for each of these lines, we've got a starting value and a output value pretty much that's going to be darker, right? And that is something we can use in the mix shader node here. Right, so Shift A finds a math with a multiply. Here we go. And I want to multiply the original alpha, so we just get the letters with this value. That's just going to make sure that we've got an alpha of 1 in the middle, but it's going to fade out, right? So multiply that there and Control-Shift-Click on that value. And right away, you can see what that is doing. We got a nice fade in and out for these numbers. Isn't that beautiful? And now just set up a camera. Right, where is our camera? Right there. That's not really what I want. I want them to be in the letters somewhere. Let's say somewhere here. Control-Alt numpad 0. Control-Alt numpad 0 is the shortcut for moving your camera to your active view. And we've got our stuff figured out. But what you can see is that we've got repetitive patterns. And that is not what we want. And that means that right now it is taking only the first column from our grid texture and applying that everywhere, right? And I want this to have a different column every single iteration, pretty much. So how do we do that? Well, we need to make sure that when we offset or when we create our X component of the what's it called, the UV map, we need to actually make sure that each spline has its own pretty much column. And we can do that quite easily, right? So at the point where we create splines, which is here. This is the latest mesh to curve we have for our original splines. So let's move everything else, including this, just a bit to the right. I want to store something right here, something that is specific for each spline. So Shift A, store named attributes, and we can set this to be an integer, and we can set this to be spline. And this means that for each spline, we can store a unique value. And I'm going to drag that out to a random value between 0 and 100. And the reason why is because we got 100 columns. Okay, and that means that for each spline, we're gonna select a different column pretty much. Okay, so a value from 0 to 1, and we call this column, I guess, column, and yeah. And then we wanna use that for when we store our X value here, right? So Shift A, find a math node, and that we add a value, and the value we add is basically going to be a column, right? Our column value. So named attribute, set to column, and to drag that in. Now we don't want to use from 0 to 100, because that is going to mean that we're still going to get a repetitive pattern, because, well, let me show you, right? This is from 0 to 1, and if we've got our X value that is nicely aligned to that first column right there, so this value is what it has right now, 0 point whatever, then if we add a value of 1 or 2 or 3 or 20, it is always gonna come back at that same section here, right? Because it's just going to get this part of the next UV or there, and that means it's always going to still be that first part of the texture. So we need to map that to be increments of, well, 1 divided by 100. So find a map range node, and we can just set this to be from 1 to 100, has to be from 0 to 1, right? And that way it is just going to offset this in the smaller increments, for example, there, or there, or there, whatever, right? Beautiful. And that is just what we want. So now each one of those has a different kind of start, right? So if we go back to 0, play this, we've got different starting points. This one has a 101, this one has a 001, 001, 101, etc., etc. 011, 01111, right? So everyone has a different column, which is perfect and exactly what we wanted. Now let me delete this annotation real quick. There we go. And let's go back to our camera view. Okay, let's play this for a sec. And there we go, they're fading in and out. And now you can actually control how quickly they fade in and out as well by controlling your age value here. So let me show that as well. But make sure that if you change this to be, for example, 14, that you also change your from max value to 14 here. All right, so now they're going to be fading in and out quicker if you like that. Now what I personally like is to have a bit more particles, so that you can control with the distribute points on faces value set to 4, for example. Play this out. You'll just get a bit more. And what I like as well is to add a little bit of a blur to my values. So let's just set the distance to be lower, closer to the camera. Let's say I want the values right there, and maybe a bit less blur. And let's maybe move this slightly as well. Let's actually make our background turn off, right? Something like that. And that way, creating that nice matrix effect. We can go more to the side like that. And then you can play around with the values of your camera. So where you want these to be in focus or out of focus, and how much of that blur you actually want as well. All right. I think that looks quite cool, to be honest. Perhaps we can just drag this a bit further away as well. Yeah, I think that looks cool. And then when you're done in Blender 4.2, we actually have a bake node, which is a lot of fun. So Shift A, find bake, just drag it in between, and we can just set this to animation, and we can just bake our entire animation of these points. And that is basically going to mean that when we play this back later, once the bake is finished, it will play back pretty much in real time. And that's just the fun part of this bake node, right? You can just bake it one time, it will be baked, and it will be set in stone until you delete it afterwards. So let me pause this and it'll be back. All right, baking is done, didn't take that much time, but you can see now that we get those frames stored in real time pretty much. We can just play this, we can play it with a little bit of denoise, and it will actually just play this beauty in real time. Isn't it amazing? And it should also work just in Eevee, right? It should be the same, except that Eevee takes a bit of time to load. There we go. Right, so we get a real-time, pretty much matrix effect. So I find that quite cool. Hopefully you as well. Hopefully you learned a little bit as well about geometry nodes and using textures and grid textures and mapping your UVs properly. It's always something that is a bit tricky, I think. So if you like this, please leave a like, a comment, subscribe. I will enjoy any one of those, and then I'll see you in the next one. Cheers!